Welcome back. In the previous video we studied about contrast adjustment of an image in MATLAB. So in this video we shall briefly revise the contrast adjustment method and talk a little more about it. What was a contrast difference in color or luminance in an image, or how well objects in an image are distinguished. So this is the low contrast image, this is a high contrast image. So you can see there is a difference in luminance and objects are clearly distinguished in this image. Histograms of low contrast and high contrast images. The histogram of low contrast images is compressed and it is confined to a small range, while the histogram of high contrast image is spread out to the whole range of gray levels. So we will find the slope of the transformation while converting a low contrast image to a high contrast image. So slope m is defined as y2 minus y1 divided by x2 minus x1, where y2 is the x1 is the minimum value of this low contrast image and x2 is the maximum value of this low contrast image. So this will act as input image. Using this input image we will generate the output image in a way that we will map the maximum value x2 to 255 and map the minimum value to 0 and calculate the values in between 0 and 255 using the equation of straight line. So equation of image transformation: slope m is equal to y2 minus y1 divided by x2 minus x1. For example, x1 is 70 and x2 is 200. So we will map this 70 to 0 and will map 200 to 255. Okay, and calculate the in between values, the values in between y1 and y2 using the equation of straight line. Remember that here x is the input image and y is the output image, which will be a high contrast image. Similarly, we will calculate the value of c. Next we will see another application of contrast adjustment, which is the negative image. So negative image is calculated in the same way, but there is a little difference, that in this case 0 will be mapped to 255. So 0 as input, x1 will be mapped to 255, this is y1, and 255 will be mapped to 0. So repeating again, 0 at x-axis is mapped to 255 at y-axis, and 255 at x-axis is mapped to 0 at y-axis. So we will calculate the slope using this equation. So 255 is the value of y2, this is y2, minus y1, this is 0, divided by x2. x2 is 0 in this case because 255 is mapped to 0. Okay, so Yes, 255 is mapped to 0. So x2 is 0 in this case and x1 is 255. So x1 is mapped to y1 and x2 is mapped to y2. Similarly, we shall calculate the slope, the value of constant c in the equation y is equal to mx plus c. So c is equal to y1 minus mx1 or y2 minus mx2. So y1 is 0 minus slope is minus 1 into 255, which is x1, and so the value of c is 255. Similarly, by using equation 4 we can calculate the value of c, which is 255. Putting the value of slope and constant c in equation 2, the equation 2 becomes y is equal to minus x plus 255. So we will calculate the negative image. We will calculate the negative image in MATLAB. Using the same code we used previously, we will make some changes in this code. So we will read the image apples.jpg, which will be the input image. We will convert this input image into the colored image into grayscale image. So we will calculate the number of rows and columns in the image using the size command. We will initialize the output image a out is equal to zeros into rows into columns. So it will be a matrix containing zeros on all its locations. So x1 in this case will be 255 and x2 will be 0. So slope will be calculated, which will be equal to minus 1. Similarly, c will be calculated using the equation y1 minus m into x1. So we will show these two images using imshow command. So there is some error in the code. You see the value of, you see in the workspace the value of m is calculated as minus 1 and the value of c is 255, but there is some problem. Sure. So let's pause the video and we will come back. So I found the problem. You see in the workspace the data type of a input is unsigned integer 8 and the data type of a out is double. So their data types are different, so they are making error in calculating the values of pixels. So we shall change the data type of a input into double. So a input is equal to double a input. Similarly, we shall change here the data type of a input using unsigned integer 8, because images are always stored in unsigned integer 8-bit form. So let's compile this. So you see, this was the original image and this is the negative image. So darker colors are replaced by brighter colors, and brighter colors which was closer to white color were changed into darker colors. So here you see the color was dark, and here you can see the color has changed into brighter color. Here the colors were bright, and here the color has changed into darker color. So we calculated the in between pixels using this equation. This is the output image, this is the input image, this is m is slope and c is the constant. So the image is converted into negative image. So you can see in the negative image 0 is mapped to 255. Here the on x-axis this 0 is mapped to 255 on y-axis, and 255 on 0 here is mapped to 255, and 255 on x-axis is mapped to 0 on y-axis, and in between pixels are calculated using the equation of straight line. So that's all for today. Please subscribe our channel. If you like the videos, press the like button and press the bell icon for getting the notifications. Thank you all. That's all for today.